Good morning, everyone. I'm Kirsten Redlegmay, a freshman student from CE12SA TIPQC, and I'm going to teach you illustration of quadratic equations. Make sure to listen carefully as this quadratic equation will be used consistently in your higher year up to university. To start the discussion, first thing to answer is the question, what is quadratic equation? The word quadratic is derived from the Latin word quadratus, which means square. According to the definition, a quadratic equation in one variable is a mathematical sentence in the second degree that can be written in the standard form of ax plus bx plus c equals 0, where a, b, and c are real numbers, which means it can have a positive or negative number, fraction, decimal, or other as long as it is a real number, and a should not be equal to 0. As mentioned earlier, the standard form of quadratic equation is ax plus bx plus c equals 0. This would be our guide for our pattern in our standard form. Let's have an example. 5x squared plus 3x plus 4 is equal to 0. As we have the equation where it's in the second degree, it is an example of quadratic equation in standard form. Now let us determine what are the terms that forms our quadratic equation, starting with 5x squared, where it is called as quadratic term because it is in the second degree or it has an exponent of 2. Next is the 3x, where it is called as the linear term, where it is the first degree, where it has an exponent of 1. Lastly is the third number 4, where it's called as a constant term, to which it is where constant number that we call as fixed value, and there is no any variable or x in the constant term. Given that this is in standard form, we can get the value of a, b, and c. Remember, in getting the value of a, b, and c, we must first get the equation in standard form. Let's first get the value of a, where we can see in our in our quadratic term, or in short, it is the numerical coefficient of the exponent. So what is the value of our a? A is equal to 5. How about b? We can see the value of b in the linear term. So what is the value of b in our equation? B is equal to 3. And lastly is our constant, where we can see in our constant term. So our C would be equal to 4. Here are some examples of quadratic equation in standard form. Let's have x squared minus 75 equals 0. And yes, it is an standard form, but there are missing terms. So let's see the expanded form of our original given. We have x squared plus 0x minus 75 equals 0. And as we've noticed, our linear term is 0x, where the value of b is equal to 0. So if we multiply it to x, what would be the answer? 0. That's why here in our original given, we don't need to write the linear term. Now let's find out the value of our a, b, and c. In our given, what is the value of a? The value of a would be 1. There is always an invisible numerical coefficient 1 beside if the only thing written is the variable x. How about b? Even if we don't see any linear term in the equation, there will still a value for b, and that is 0 as we've seen in the expanded form earlier. And the value for our constant term will be negative 75. So a equal 1, b equals 0, and c equals 75, negative 75. Let's proceed with another example. We have x squared minus x equals 0. Now, what's the term that's missing in our example? Here in standard form, our constant term is missing because its value is 0, and we didn't need to write it anymore in our original equation. Now, let's determine the value of a, b, and c in our example. The value of a in this given is 8. How about the value of b? The value of our b is negative 1, and the value of c, as what is written here, is 0. So a equals 8, b equals negative 1, and c equals 0. Our next example is 6x squared equals 0. Now, how many terms are missing? So we have two terms that are missing, and those are linear and constant term, which is considered to be 0 as we've written them in our original example. And this is what we are talking about earlier. Our a should not be equal to 0 because if this happens, there will be no quadratic term, thus making it an example of quadratic equation. So going back, the value of a would be 6, then b equals 0, and c equals 0. Now, let's determine if the following examples are quadratic or not quadratic. 9x squared minus 5x minus 2 equals 0. The answer is it is a quadratic equation, and this example is in standard form. Second given, x squared minus 9x equals 10. Is this a quadratic equation or not? The answer is it is a quadratic equation. This given is considered to be a quadratic equation but not in the standard form. Third given, 24 minus 8x equals to 0. Is this a quadratic equation or not? The answer is not quadratic equation because this given is what we call as a linear equation as it is in the first degree. Now, proceeding to our next part to which we are transforming quadratic equations into its standard form. Let's have a recap of our standard form, which is ax plus bx plus c equals 0. It is important to remember this as we go along calculating quadratic equations and also as a guide for our next given. Our first example is 4x squared plus 3x plus 5 equals 0. Is it in standard form? Yes, the given quadratic equation is in standard form. So if the given is like this, we can now get the value of a, b, and c. The value of a is 4, where we can see in our quadratic term, or the numerical coefficient of x squared. Next, the value of b, which is 3, the numerical coefficient of x. Then lastly, the value of c is equal to 5, which is the constant term. Let's have our next example. 8x minus 3x squared equals 6. Obviously, our given is not in its standard form, so we have to arrange. The first thing we need to do is write it in standard form. How? Our goal is to make the other side of the equation 0, and we will not just transfer 6 to the other side because we have this what we call our property of equation. What property would it be? Let's recall. We will be using the addition property of equality. Whereas to make the other side 0, what should we add to 6 to become 0? And that is negative 6. We need to add both sides negative 6, making our equation 8x minus 3x squared minus 6 equals 6 minus 6. If we added negative 6 to its one side, we also need to add negative 6 to its other side to be balanced. So 6 minus 6 will become 0, and that's our goal to make the right side of the equation 0. We just only needed to arrange the left side of the equation where the first term would be quadratic term, followed by the linear term, then the constant term. So what will be its arrangement? Let's place negative 3x squared in front, followed by 8x, which is positive, so it will be positive 8x, and then minus 6 is equal to 0. So the value of a in our equation would be negative 3. Next, the value of b is 8. Then the value of c is negative 6. And that's our second example. Let's proceed with our third and last example. Our given is 5x plus 5 closing over parentheses x minus 9 equals negative 6x. Now there will be a slight difficulty of directions to follow before we get to its proper answer. So what are the things we need to do? First is to expand the product and make one side of the equation 0, meaning we have to multiply x plus 5 to x minus 9, and then make the other side of the equation 0. So what do we need for us to multiply? Let's use the FOIL method. FOIL method is what we use our technique to multiply binomials. And what is the meaning of FOIL? F stands for first, O stands for outer, I means inner, and L means last term. So if we multiply those two binomials, we would get an answer of x squared minus 4x minus 45 equals 6x. Now how could we elaborate the FOIL method we said earlier? Our first terms would be x times x, so we would have x squared. Our next terms would be, as what it says, outer, x times 9, and the product would be negative 9x. Next is our inner term, which are positive 5 and positive x. That would result to positive 5x. And then our last term would be positive 5 and negative 9. So if we multiply 5 to negative 9, the answer would be negative 45. So we would have an equation of x squared minus 9x plus 5x minus 45 equals negative 6x. Our next step would be combining like term. We need to simplify the other side of the equation. So we need to find those terms that are the same. X squared doesn't have any terms that is in the same way. That's why we would be just keeping it as it is. Next is our linear terms, which there are two of them, so we have to combine negative 9x plus 5x. The answer would be negative 4x. Then just copy our constant because it doesn't have any like terms. So will result to this, it will result to this equation x squared minus 4x minus 45 equals negative 6x. Next is, as what we've done earlier, we need to make the other side of the equation 0. So we need to use the addition property of equality. What should we add to negative 6x to make it 0? And of course, we need to add positive 6x to both sides to make it balance, resulting to this. We're almost there yet, turning this into a standard form. So let's finish the equation. We just needed to combine like terms, and it's always like that. We need to simplify our answer. X squared doesn't have any like terms the same way, so we would be just keeping it as is again. Next are linear term, which there are two of them again, so just need to combine negative 4x plus 6x. The answer would be positive 2x. Then just copy our constant term, which is negative 40. Finally, this would result to x squared plus 2x minus 45 equals to 0, the standard form of. Now let's identify the value of a, b, and c. The value of a here is 1, and the value of b is 2. Last is the value of c, which is negative 25, for and that's it for our last example. This lesson has come to an end. I hope each and every one of you have learned something from me, as I only wanted to help and share my knowledge during these hard times. Always remember to keep safe and follow our protocols. Good luck and keep striving for we are part of our future generations.